MAT0018 Review for Test 3 Decimals. This is Part 3 starting at Problem 16. So our first question is evaluate an expression. Remember, to evaluate you substitute. So we're going to take the 0.3, it will substitute into the x, and negative 2.4 into the y. So we have 4. This is going to be a multiplication. So we'll use a parentheses, 0.3 minus, and you're plugging in a negative, so I would use parentheses there. You don't want to lose a sign. This one was the minus from the problem, and you plugged in a negative value. Now you're going to go with order of operations. You would do your multiplication first, so 4 times 0.3. We can do that on the side. We're just writing it vertically. 4 3s are 12, so we have to carry 4 times 0, 0 plus the 1. And we go in one place. So 1.2 minus a negative, remember, or opposite of negative makes plus. Now, we have like signs. Like signs are going to add and keep the sign. So addition, we're going to write it vertically, lining up the decimal. We will add and bring the decimal straight down. So 3.6. Problem 17, we're going to convert to decimals. So first we have 2/5. You're going to divide your denominator into the numerator. So we're going to do 5 into 2. And it won't go. Put your decimal, take it up, and then you can add zeros after your decimal. So we'll add a 0. 5 into 20 will go 4. So 4 5s are 20. This one works even. 2/5 is the same as 0.4, or you could put 0.4. It's the same. 17b, we want to convert 1 4/10 over to a decimal. So 1 is going to be your whole number. It will be on the left of the decimal. What you could do with this one, because it is in tenths, you could actually use place value. It's going to be 1.4. If you did not realize that, what would always work is to convert that fraction over to a decimal. So we could do 10 into 4. It won't go. Put your decimal, take it up, and you can add some zeros. 10 into 40 will go 4 times. 4 times 10 is 40. So the 1 is the whole number on the left of the decimal, and then I converted the fraction. But it would have been okay to just use your place value there. Next we have 1/3. To convert to a decimal, you divide the denominator into the numerator. So 3 into 1. It won't go. Put your decimal, take it up, and then you can add zeros. 3 into 10 will go 3 times. Multiply back. 3 times 3 is 9. Subtract. You can add another 0 and bring down. 3 into 10 will go 3 times. 3 times 3 is 9. Subtract. And you're going to start to realize that you're always going to get 1 for a remainder, which means you're always going to keep getting the 3's up here. This is called a repeating decimal, and you can write it with a bar over the part that repeats. So we actually only need one of the 3's. So 0.3, and put a bar over it. That means that digit repeats. If you had to do some math with this, you would round instead. You can't calculate with the bar on there, and you would just round to a place value. Next, we're going to look at some equations that have decimals. So first of all, make sure it's an equation. Needs an equal symbol. It might or might not say solve, but these are solved problems. You're going to isolate the variable. When you do have an equation with decimals, what we like to do first is clear the decimal out. And we do that by multiplying through by a power of 10. You're going to pick the power of 10, and that means 1, 10, 100, 1,000, with as many zeros as your longest decimal. That means digits after the decimal. So we only have a decimal in our first one, and it has one digit after the decimal. The X is not a digit. So one digit, that means we need to use a 10. 1 0 in the 10 for the one digit we want it to move. So we're going to multiply both of these on both sides by a 10. This is to get the decimal out of there. And when you multiply by a power of 10, it moves your decimal one place to the right. So 10 times 0.4x gives you 4x. The 0 moves your decimal over 1. 10 times 50 will give you 500, or it moves your decimal from the 50 over 1 to the right. Now you have an equation without decimals. You're solving, so you're going to divide out your coefficient. So we're going to divide on both sides by 4. So that's x equals, this would be a long division, 4 into 500. 4 into 5 will go once, multiply back, subtract, bring down. 4 into 10 will go 2 times. 2 times 4 is 8. Subtract, bring down. And 4 into 20 will go 5. So x equals 125. Number 19 is another equation which has some decimals. So we are going to look and see which decimal is the longest. So 9.64 has 2 digits after, and 2.32 also has 2 digits after. This time, for the 2 digits, you're going to have to use 100, and you have to use it all the way across. So we'll use 100 beside each one. I'm just writing it right beside it because all it's going to do is move the decimal. So on the 7, the decimal is at the end, or 100 times 7 is going to give you 700x. On the next one, 100 times 9.64, the 2 zeros is going to move your decimal 2 places to the right. 100 times 5x will be 500x. And 100 times 2.32, the 2 zeros will move your decimal 2 places to the right. So 232. Now your decimals are all gone. You have a plain equation. You do have a variable on both sides. You want to get rid of one of those. I would probably choose to get rid of the 500. You can kind of see here 700 minus 500 is 200. If you need to write that step, do. If you're ready to leave that step out and just do it, then that is also fine. So what I'm doing is subtracting 500x. I'm putting it after the term it's alike. And I will do that on both sides. So this is what I had already. And I'm going to subtract 500x to make it cancel. On the left-hand side, I get 200x minus 964 equals 232. Now we'll go on the side with the x, and we want to take off that 964. So we're going to add 964 to both sides. Then we'll clean up. That one cancels. So we have 200x left on the left, and on the right, those are like signs, so they're going to add. So we're going to have a 6, a 9, and 9, 10, 11. And we need to divide on both sides by our coefficient. So we're going to divide by 200. This will give us x equals, and this did not go evenly. I'm going to just scroll a tiny bit. Let's have a little more room. So I'm going to divide it out since we started with decimals. So 200 into 1196. And I'm actually going to have to go into the whole thing. So I'm going to guess, let's see, 8 would be too big. That would be 16, 7, 5 would be 10, 6 would be 12. So we're going to have to go with 5. And we can put a decimal, and then we're allowed to add a 0. Bring it down. We can divide again. So 200 into 1960. And 9 2s are 18, so we're going to say a 9 there. 9 2s are 18. Subtract. And we can add one more 0 and bring it down. 200 into 1600 will go 8 times. And I multiplied back there. So 5.98 is my answer.